Okay, it's the Math 1113 Zoom meeting. Section 7.1, we're kind of overlapping 7.1 and 7.2 because we took off spring break half of last week, or at least the last 2 days of last week. So we're going to do a Zoom meeting today on 7.1. 7.1 today. Tomorrow, 10 a.m. That'll be the 7.1st, 7.2 Zoom meeting of the week. Wednesday be the quiz. 7.1 due Friday. 4/9. And Friday we will have our second 10 a.m. Zoom on 7.2 and quiz on 7.2 due Sunday for 11. All right, so 7.1, if you remember, was about identities. Identities. We'll charge into some of the homework. Remember, identities are two sides, and they're equal for every angle. Very first problems were to simplify some things. Why don't we try one of those first? Page 579, we'll try number 9. Simplify sine of u, cotangent u, cosine of u. Well, a cotangent, remember you can't simplify sine and cosine, they're the basic building blocks. Cotangent is a cosine of u over a sine of u, cosine of u. I would look for a cancel, but obviously sine and cosine don't cancel each other. So get common denominator. That would be sine u over sine u. In effect, putting this over. So you put it up, that makes a sine squared u. Put it over, and then you put it up. You're doing it to this bottom. So you need to do it to the top. Now make a sine squared u. They multiply together. Add a cosine squared u over sine u. Okay, sine u is your common denominator, so nothing to do with these. And that, of course, is a sine squared of u. Add a cosine squared of u all over sine u. Well, a sine squared add a cosine squared is 1 over sine u, and that's fully simplified. Doesn't bother me that it's in the denominator, but I would bet that the book wants a cosecant of u. I wouldn't mark it wrong here and then mark that right. You get a little arbitrary where you quit. What others? I'm trying to work with ones we haven't done. I'm trying to remember which ones I did last week. Why don't we simplify? This is on page 579. I don't remember doing 15. Sine of t, add a tangent t, and divide by a tangent t. Well, once again, one of the main things is to convert to sines and cosines. So how about a sine t? Add a sine t over cosine t on top, and you're dividing by a sine t, cosine t. Well, you get common denominator over here, and then up you'll have a sine cosine t, add a sine t all over cosine, and that's over sine cosine t. I don't know if we're going to get anywhere or not. Let's factor out sine t off that line. t, cosine t add 1, sine t times cosine t, sine t cosine t, sine t times 1 is sine t, divided by cosine t, all over sine cosine t. Now, you may notice this, you can divide it straight out, but I think I'll convert them to tangents. If you notice this sine t over that cosine t, that's tangent t. And this is a tangent t. So I'm going to write that tangent t, 1 plus cosine, if I keep it the same order, tangent t, cosine of t add 1, all divided by tangent t. You can compare the two lines. That's sine t over cosine t, that's a tangent t. Sine t over cosine t, that's a tangent t. You could also flip them around and flip the cosines around. The cosines cancel, the sines would cancel as well. You can play it that way. And you're left with cosine of t add 1. So much you can do with that. All right. You can try one in the next. Well, let's see. That wasn't the next section. I can't remember if we did 23. Why don't we try some identities? They're really from 31 on. I don't have the assignment right in front of me. I can't remember where I quit on. Let's see. Quit on them to 59 because there's a bunch of them. So it's like not quite halfway down the second column. 3 to 27, simplifying, and then 31 to 59. Assignment. You can try some of the others if you want. How much practice you think you need? Let me think. Why don't we try one like 37? I don't remember mentioning the even odd ones. You got a cosine of negative x. A sine of a negative x is equal to a cosine. This was so easy, it's hard. If you'll remember, this is equal to a cosine of x because cosine's even. And this is equal to a negative sine of x. And there's a negative in front. So in effect, you have a cosine of x, add a sine of x. And on the other side, a cosine of x, add a sine of x. There's much more you can do with that. It's a matter of knowing cosine's even and sine is odd. All right, what else could we do? I think I remember, let's see, I'll try 41. One minus cosine of beta, cosine of beta, cosecant squared of beta. Well, I hope it's pretty obvious you're never going to turn this to this. So we might as well try foiling here and see what we can get. 1 plus cosine beta. 1 times 1 is 1. 1 times cosine beta, minus cosine beta times 1, minus cosine squared beta, minus cosine squared beta. Cosecant squared beta. Remember, there is a kind of like a wall down through here. You can tell those can cancel. Hope you know that a 1 minus a cosine squared is a sine squared. 1 over a cosecant square root of beta. You can really almost quit right there because that should be obvious that those are equal, or you could convert this to 1 over cosecant square root of beta, and it's equal to 1 over cosecant square root of beta. Either way. Why don't we try one like 43? I've worked some of these, can't really remember what I did last week, so I'm repeating myself. I remember working on 45. That was I remember embarrassing myself. I think I turned it into equals 1 plus tangent squared y. Still page 579. Yeah, I think I did 45 and managed to embarrass myself with how long and difficult I made it look. 1 minus a sine squared is a cosine squared. Equals 1 plus a tangent squared y. Yeah, and if I convert this to a secant squared y, 1 plus a tangent squared is equal to a secant squared. Listen, you could convert the sines to cosines, and that'd make it look a lot more complicated than it really is. All right. Well, I don't know. My head's telling me not to get into 47, but what the heck? I'll try it. 47. 1 minus a sine squared t, add a cosine squared t, and then square it. Add 4 a sine squared t and a cosine squared t. Comes up equal to a 4 cosine squared t. All right. I hope it's obvious. There really isn't much you could do. They convert it to 4 divided by secant squared, but you're never going to turn that into this. Now, a FOIL on that is going to be pretty darn complicated. I'm going to try, see this 1 minus sine squared? We'll make that equal to a cosine squared because it's a like term to this. That gives me a cosine squared, add a cosine squared, t squared, 4, I lost a t there, 4 sine squared t cosine squared t, still lose my t's. Now a cosine squared add a cosine squared, that's a 2 cosine squared, and that is squared. Add a 4 sine squared t cosine squared t, again the side's just continuing on down. When I square this, I get a 4 cosine to the 4th of t, which are raising the powers. Sine squared t cosine squared t. Well, the common factor is a 4 and a cosine squared, and that, notice that that is what I have over here. T, I'm left with cosine squared of t, add a sine. And sure enough, cosine squared plus a sine squared is 1. 4 cosine squared of t times 1 is this. And on the other side, 4 cosine squared of t. There. I have a feeling if I had tried to FOIL that out, I'd have made myself look like an idiot. I could have gotten there or not. I don't remember working, I think I remember working 51 and making myself look like an idiot on 51, and I think that was the last one I got to last time. So we'll skip 51 on this video. 49, page 579, takes a cosecant of x, cosine squared of x, add a sine of x, is equal to a straight cosecant, which again will never turn into this. I can't really do anything with cosine squared sine. Well, let's convert this to 1 over sine. So 1 over sine of x plus sine of x equals, again, this is coming on down. Gives you a cosine square root of x, add a sine x, and all divided by a sine of x. My 1 over sine of x is my cosecant. And if that had worked out cosine squared plus sine squared, I'd have a 1 and I'd be done. No, I got it just on this. I got my cosecant just on this. Oh, my cosecant is just on that. That's my mistake. The parentheses should be there. It's not distributed through. Ali. Okay, so my cosecant is strictly on the cosine squared. Add a sine. So I really have cosine squared over sine. Add a sine. Equals this. Aha. Always helpful to copy stuff accurately. I put that over there and that up there. I wind up with cosine squared of x, add a sine squared of x, all over sine equals, boom, there you are. 1 over a sine of x is equal to my cosecant of x. Yes. Okay, yeah, little blip in that. And I think I embarrassed myself on 51 last time, so I won't repeat that. Let's jump to 53. The secant of t, subtract the cosine of t, secant of t comes up a sine squared. Now I can convert this to cosines if I want to, or I could just distribute this. So I see a secant over secant, that's a 1 minus cosine t divided by a secant t. Well, secant t, 1 divided by cosine t is a 1 divided by cosine t. You see that flips around 1 minus cosine t squared, because it's going to flip around times cosine t over 1. Well, 1 minus the cosine squared t is a sine squared of t equals a, on the other side of sine squared of t. Yeah. Am I going these too fast? I guess you could always stop the video and look at it. $55. The cosine squared of x minus the sine squared of x is equal to twice the cosine squared of x minus 1. This is kind of a preview of coming identities in maybe 7.2, but I can't really show you that now. Notice that we want a cosine squared of x here, so we want to get rid of the sine squared. Let's write that as 1 minus cosine squared of x. So I got cosine squared of x minus a 1 minus cosine squared of x. That gives me a cosine squared of x minus 1. Add a cosine squared of x. Cosine squared, add cosine squared, there's 2 cosine squared of x minus 1 equals on the other side 2 cosine squared of x minus 1. You know, and there may be other ways to do. I mean, I could have converted this side to 1 minus sine squared, played around, and this is 1 minus sine. You know, there's other ways to do it. You don't have to do it exactly the way that I do it. 57. Sine to a fourth of theta, subtract a cosine to the fourth of theta. Sine squared of theta minus a cosine squared of theta. I don't know how much gibberish this looks like to you, but honest, yeah, I've done a few of these. Whenever I see, you know, perfect squares here, even powers subtracted, I think difference of squares. Which means you'd add and subtract the square roots. So that's like a sine squared of theta, add a cosine squared of theta, sine squared of theta, subtract a cosine squared of theta. If you notice, this is 1. Sure enough, sine squared of theta minus cosine squared of theta equals, if you draw your line through, exactly the same thing on the other side. It's so easy, it's hard. 59 looks a little nasty. I think that's where I had the assignment quit. Let's see how hard I can make 59 look. Sine of t, add a cosine of t, and then square. Sine t cosine t is equal to twice plus secant t cosecant t. Let's go ahead and FOIL. Sine squared of t. Can you tell you're going to get a twice sine of t cosine of t, and then a cosine squared of t. Sine of t cosine of t. Your sine squared plus your cosine squared on the end. 1 plus twice sine of t over sine of t. Spread this out, or distribute it. 1 over sine of t cosine of t. 2 sine, I'll write it out painfully, cosine of t over sine t. All of this cancels. 1 over sine is your cosecant. 1 over cosine is your secant. And with all that canceling, you're left with 2. And if you will notice, that's identical to this. A little switched in order, but don't let that bother you. I'll just keep working a few more just for practice. Try to make this last about 30 minutes. How about 61? 1 plus tangent squared. Tangent squared. Cosine squared u minus sine squared u. That's a u. I know 1 plus tangent squared is a secant squared. Could do that. That's a difference of squares, 1 plus tangent, 1 minus tangent. But all you got is sines and cosines over here. I think I'll convert to sines and cosines. Cosines. 1 plus a sine squared over a cosine squared. 1 minus a sine squared. Cosine squared u. Okay. common denominator, cosine squared u plus sine all over cosine u. On the bottom, you'd have cosine minus sine all over cosine squared of u. You see, when you common denominator over and then up, have here over and then up, equals on this side. Now this level is simply 1. If you see, so you're getting 1 over cosine squared of u over cosine squared of u over cosine squared of u. And you tell, you flip this around, 1 over cosine squared of u times cosine over cosine squared u minus u. These cancel and you're left with your 1 over minus sine squared u. More. I get kind of sick of it, I guess. 63. Secant x, add cosecant x, and on bottom, tangent x, cotangent x, is a sine, add a cosine. Well, you are never going to convert this to this. Let's convert to sines and cosine. 1 over a cosine, 1 over a sine, sine over a cosine, cosine over a sine. All right, common denominator. Again, you put these together. This up there, that up there. So that's a plus a cosine. I'll write it sine times cosine. Bottom, same thing. If you put them together, then you that up there, that up there. That makes a sine squared. Cosine squared over, all right, sine x, cosine x. All right, can you tell that this level is 1? So I'll write out your fraction. Can you tell that's going to cancel that when you flip things? But I'll write it out. Sine x, add a cosine x. Cosine x times sine x cosine x over 1. And that will equal sine x at cosine of x equals on the other side. Like I say, who thinks up these things? I don't know how in the world you'd think up something like that. But I guess people have had 400 years to think them up. And we'll keep trying a few more. 65 minus a cosine over a sine. Add a sine over 1 minus a cosine. Comes up twice. A cosecant. Same pattern. Put those together, that up there, that up there. Now that's going to make, I'm going to write it a 1 minus cosine of x quantity squared, because you have 1 minus times identical. They're identical when you put them up there. You're going to add a sine squared. On the bottom, your common denominator will be a sine 1 minus cosine. Equals on the side. Well, if I put them back underneath, I go right back to this and that. Let's FOIL. Hope y'all are good FOILers. 1 minus twice cosine of x, cosine squared x, add a sine. Let's don't, I'm hoping to get a common factor and cancel something here. So let's don't distribute on bottom. It would distribute, let's don't, let's keep it separate. Otherwise, I might have to factor it back out. Your cosine squared plus sine squared, that's your 1. Add 1 all over your sine x, cosine x. 1 plus 1 is 2. Or to be Captain Obvious, sine x, 1 minus x. Let's factor out your 2 over sine x, 1 minus cosine of x. And now I got my common factor to cancel, and a 2 over sine x is equal to twice the cosecant of x. I don't know if I'm going too fast or not. We'll just wear it 30 minutes. We'll just try a couple more. I'm having so much fun. 67. Minus sine squared comes up a tangent squared, sine squared. The difference of a tangent squared and sine squared is identical to a product of tangent squared and sine squared. Isn't that absolutely fascinating? It is fascinating to me. You usually will never turn a product like this into some subtraction. But if you could turn a subtraction of this, if you factor something out. Let's go to sines and cosines. Equal to that product. Common denominator, which would give you sine squared of u minus sine cosine squared of u all over cosine squared of u. So put it over, you get a cosine squared on bottom, and put it up, and you get a write them together there, a product. Gives you a common factor of a sine squared. 1 minus a cosine squared. Cosine squared of u. And your sine squared over your cosine squared, that's your tangent squared. And your 1 minus cosine squared is equal to your sine squared. There you are. $69. I just can't quit. 1 plus a tangent x. 1 minus a tangent x. The cosine of x, add a sine. Cosine of x, subtract a sine. Let's convert this sines to sides and cosines. 1 plus sine over 1 minus cosine of x. Common denominator, cosine of x, add sine of x, all over cosine of x. By cosine of x, subtract sine of x, all over cosine of x. And I think you got it. You see how this would flip around, and this would cancel that, leaving you with your cosine of x, add a sine of x, over your cosine of x, subtract sine of x. There's other ways you could do it. See how you had ones here, and your plus and minuses match. You could have divided everything by a cosine. You almost see it in your head. Cosine gives you the 1, divided by cosine here gives you the tangent. Cosine here gives you the 1, divided by cosine here gives you the tangent. So if you can see something like that, it probably was a little shorter. I'm just trying to do them all the same way, trying to keep the confusion down. How about 71? 1 over secant plus tangent plus 1 over a secant minus tangent is equal to twice the secant. Well, you will never turn that into this. The common denominator is secant, or we could just go ahead and do it sines and cosines. Why don't we go ahead and get common denominator as is, but leave the bottom secant x tangent, secant x minus tangent. The top would be secant minus tangent this way, and then this way would be plus secant plus tangent. And you can see a nice cancel, and that's twice the secant, which is what I have here. So I'm really close if I can show that the bottom is 1. I'll have it. Let's FOIL out secant squared minus secant tangent, add secant tangent, and subtract tangent squared. Middle terms cancel. Twice secant squared minus tangent squared. Twice secant, and it would if this is equal to 1. Now I do not have it memorized. So 1 plus a tangent, this is what I do have memorized. I have memorized is equal to a secant squared. So if I subtract this tangent squared over, 1 would be equal to a secant squared minus a tangent squared. Yeah. Subtract tangent squared from both sides, I'd come up with 1. So yes, this is equal to 1, and twice secant x equals twice secant x. Yeah. One more. And then we won't turn the page of horrors on the next page. 1 plus sine of x, 1 minus sine of x. There's a minus and a 1 minus sine of x, and that's divided by 1 plus, so it's the reverse of this one. Sine of x comes up equal to a 4, out of room, tangent secant. Product of 4 tangent and secant. Make sure I've copied it right. Get common denominator. Oops, off the page. Get common denominator. All right, let's make it all. You got both these pieces on bottom. 1 minus sine x. Sine x. And then up there, let's see how this is identical. See, you're going up there. This is identical to that. Let's make it 1 plus sine x squared, subtract. You see how that's identical to that? Let's make that 1 minus sine x squared. Could FOIL. But notice how this is squared and this is squared. Yeah, it's a specialized trick, but I could easily write it out as difference of squares. Or I could just go ahead and FOIL and watch the terms. Be a little longer, might be more. Maybe I should just FOIL it. Yeah, I think I'll just FOIL it. Okay, y'all are good FOILers. 1, let's plus a twice sine x plus a sine squared. Subtract big parentheses because this distributes. 1 minus twice sine x, add a sine squared, equals stuff on this other side. Let's FOIL the bottom and see what happens. 1 plus a sine, minus a sine, minus sine squared. All right. Let's distribute that sine, get the signs right. 1 plus twice squared minus 1, add twice sine. I'm sorry, I lost a sign there. That's a plus sine squared. Minus 1 plus twice sine x, and then minus sine squared. Your bottom, notice, sines cancel. Can you spot that 1 minus sine squared? It's a cosine square. Equals, again, a 4 tangent secant. Well, I see the sine squareds cancel. 1's cancel. So a 2 sine, add a 2 sine is a 4 sine divided by cosine squared. Tangent times a secant. Okay, if I go 4 sine and write 1 cosine here, there'd be another 1 over cosine. Spread out cosine squared is cosine is cosine. There is your 4 tangent and 1 over cosine to secant. There we are. Okay, well, I won't turn the page of horrors. That's almost 45 minutes of it. Hope that's enough practice for y'all. We'll do a 7.2 and start 7.2 tomorrow, doing more formulas. I think that's where chapter 7 formulas really start and get hot and heavy. So I hope this is good practice, and we'll end the meeting.